All right, we are going to start the statistics course. The first chapter is Introduction to Statistics. So it's a lot of vocabulary. The first chapter is a lot of vocabulary. So don't get bored too quick. We'll get into some number crunching and stuff starting in chapter 2. But first chapter is on just intro to statistics. So we only have 3 sections in this chapter. It's going to go pretty quick. Today we're just going to do the overview of statistics. Then we're going to talk about data classification on Friday and then experimental design on Monday. All right. So the overview of statistics is basically some vocabulary words like population and sample, what the difference is between those 2 words. Parameter and statistics, again, what's the difference between those? Descriptive statistics and inferential statistics, those 2 branches of statistics, what is the difference between those? Okay, and being able to look at a situation and tell between the different parts of it. So, data is basically the information that you collect, whether it be from observations, counting something, measuring something, or taking some responses on a survey. Data is just that information that you are collecting. And when you're looking at data, there's nothing. It doesn't mean anything. So here's some raw data. There's 6 numbers there. Just to give me 6 numbers means nothing. I don't know where they came from. I don't know what they mean, what they're doing at all. I mean, are they ages? Are they weights? Now, who knows? So you've got to at least have some sort of context. The context is these are test scores for period 4. That makes sense, okay? Small class, 6 people. Then, again, the context, well, what do we want to do with those? You know, can we interpret it somehow, give it some sort of meaning? So a lot of times when you have test scores, we want to look at the test average. So that would be information that we can gather from this. Now that we know what they are, we can say, oh, the average test score is 67. Okay? So you need to know what the data is, where it's coming from, and what do you want to do with it. Okay? So statistics is basically the science of collecting, organizing, presenting, analyzing, interpreting numerical data to assist in making more effective decisions. In every aspect out there in the world, you're going to be able to find statistics. Whether you are in the medical field, the education field, the economic field, you can't get away from it. Statistics is everywhere. They look at statistics to determine how big of a school they should build. They look at statistics to figure out how we should grade you guys. In every one of our teacher meetings, all we hear is, it's data driven, it's data driven. You've got to look at what's happened and then figure out where we should go from here. Okay, so statistics is everywhere. It's a kind of a good thing to understand because, again, you're going to be adults at some point and people are going to talk to you about things like medical decisions to be made, and you're going to say, well, what are the chances? What are the statistics behind it? Okay. Population versus sample. So these are our first 2 big words besides the word statistic. Population is the collection of all outcomes possible. Okay. So what are you looking at? What population are you looking to study? Is it all the adults in the United States? Is it all the juniors at Jackson High School? So the population includes everybody in the group that you're interested in studying. The sample is a subset or part of the population. Most of the time, almost all of the time, we use a sample when we're dealing with our statistics and collecting data because it's near impossible to use the whole population. Okay? It's cost prohibitive, time prohibitive, and just doesn't make sense. So you want to pick a sample of the population to actually survey or test or measure. And then we can predict things for the whole population based on that sample. Okay, so the population is everybody. The sample is just a subset or a part of that population. And we'll talk later about how we need to pick that sample when we do an experiment. Okay, but today we just need to know what the word sample means. So, identifying data sets. In a recent survey, 834 employees in the United States were asked if they thought their jobs were highly stressful. Of the 834 respondents, 517 said yes. Identify the population in the sample. Describe the sample data set. So when we're looking at this, they're taking a survey of all of the employees in the United States. So the population is everybody who has a job, everyone who's employed in the United States. And they're asking them the question, are your jobs stressful? Well, we can't ask everybody, so we're going to pick 834 people to be in our samples. So it's got to be 834 employees. You can't pick people in the sample that aren't part of the group you're trying to test. So it's 834 employees in the United States that are taking the survey. And then describe the data set. Well, what data are you getting? Data is the actual number, the responses you're getting. Okay, data is the responses. So we have 517 that said, yes, my job is stressful. And then you have 317 that said, no, my job is not stressful. So there you go. That's your data set. So you should be able to pick out the population, the sample, and describe the data set. Okay? That's our goal here. So here's 3 examples. Turn to your partner, talk about it, see if you can figure out the population, the sample, and the data set. I'll give you a couple minutes. Okay, let's see if you're right. So in the first one, we have a population of all American households. The sample is the 1,353 households that were actually surveyed. And the data set is 78% own a computer, 22% do not own a computer. Okay. In the second one, we have a survey of 2,625 elementary school children. So the population is going to be all elementary school children. The survey is only talking about the sample of 2,625 elementary school children. And the data set is 28% are obese and 72% are not obese. The last one's a little bit trickier. When we're talking about the weight of every 6 person involved in a 3-hour period is 146. So basically the population is going to be everybody who's in this mall who's going to the mall, okay? The sample, you're just going to describe it, every 6 person entering the mall within a certain 3-hour period. And then the data set, they're not giving the actual percentages or whatever, they're telling you the average of the weights of those people were 146 pounds. Okay? All right. Parameter versus statistic. So, easy way to remember this. A parameter is based on the population. It's describing the whole entire population. A statistic is describing a sample of the population. So you have to really be careful when you're reading these scenarios. So the first one says there are exactly 100 senators in the 109th Congress, and 55% of them are Republicans. So they surveyed or got the information on all 100 senators. 55% are Republican. So that's a parameter because we used all the senators, all 100 of them were in our little survey. Okay. The other example is in the Literary Digest polled 2.3 million adults in the U.S. and 57% said they would rather vote for Alf Landon for president. Okay, so this again is a statistic because it's based on a sample. Statistic, sample, they both start with S. Parameter, population, they both start with P. That's how I remember. Okay? So when you're dealing with an entire population, parameter, subset, or a sample of the population, statistic. Easy enough. Okay. So decide whether the numerical value describes a population parameter or a statistic. Recent survey of a sample, the word sample is right there, of college career centers reported the average starting salary for petroleum engineering majors is $83,121. So since it's a sample, it's going to be a statistic. Okay? So again, subset of the population. Same deal, 2,182 students who were accepted admission offers to Northwestern University in 2009 have an average SAT score of 1,442. So is that a population we're dealing with there or a sample of the population? So they're talking about all the students who were accepted. So that's a population because they're only dealing with that particular college, those particular students. It's not a subset of those students. Okay, so that is going to be a population parameter. Okay, because all the students were being used from that particular class, 2009. Okay? All right. We have two branches of statistics. We have descriptive statistics, which involves organizing, summarizing, and displaying data. Okay? And we have inferential statistics, where we actually make the conclusions. So we're using a sample to draw conclusions about a population. So when it's descriptive, it's organizing, summarizing, and displaying the data. And you're describing what you collected. Okay? Whether you're describing it in words or on a chart or a graph, you got the information, you're describing it somehow. Inferential is taking that and then making conclusions about the population. So we have two major branches. For each study, identify the population in the sample, then determine which part of the study represents the descriptive branch of statistics. And what conclusions might be drawn from the study using inferential statistics. So understand, you are coming up with a conclusion here. Okay? So if you look, a study of 2,560 U.S. adults found that the adults not using the internet, 23% are from households earning less than $30,000 annually, as shown in the figure. So they describe their results, part of the results, you should say, and they've shown all the results with this chart. Okay? So, what is the population? What is the sample? So the population is all the U.S. adults. The sample is just those 2,560 that were asked in the study about the internet use. Okay? And then your part that is a descriptive branch is 23% of the households earning less than $30,000 are not using the internet. I'm sorry, 23% of the population in our sample are not using the internet. Let's backtrack that. I said it right the first time. Out of this sample, 23% of the households earning less than $30,000 annually, they're not using the internet. So, what conclusion can you draw? Right, from that, we would say adults earning less than $30,000 may not be able to afford internet. You know, we're going to do our car payment before we do internet. All right, so that's one conclusion we can draw. It's kind of a logical one. All right, so you have to be able to do the population, sample, and a possible conclusion. Okay. Same deal here. A study of 300 Wall Street analysts found the percentage who incorrectly forecasted high-tech earnings in a recent year was 44%. So our population is all of the analysts on Wall Street. Our sample is the 300 that we actually surveyed. Our descriptive part of this is they found 44% of them incorrectly forecasted high-tech earnings in the recent year. So what conclusion can you draw from that? Sometimes they're kind of hard to draw the conclusions. The one we draw here is that forecasting in the stock market is difficult and risky even for professionals. So they almost half of them got it wrong. Almost half, right? Forecasted incorrectly, just like the weatherman. Half the time they're wrong. So the descriptive part there is 44% incorrectly forecasted high-tech earnings. The conclusion we can say is it's hard to forecast the stock market. Okay. All right. Descriptive or inferential. So the average salary of a random sample of 50 high school teachers in 2010 was $52,400. So they are basically just telling you information. They're describing an outcome that they found. So this would be descriptive. Okay? Based on a random sample, it was concluded that the average cost of a hotel room in Chicago was greater than one in Atlanta. Well, the word concluded is giving you a hint. You made a conclusion. You were given some information and you said, hey, wait, I can see Chicago is more expensive than Atlanta for the average cost of a hotel room. Okay. A study has concluded the average credit card debt of the college graduates has increased. Again, concluded. We've got that word in there. Anytime you have a conclusion, it's going to be inferential. Okay? The actual descriptive data would be what is the credit card debt in 2009, 2010. The conclusion is, one's higher than the other one. Okay? All right. So that is it for this lesson. We will continue with 1 and 2 on Friday.